mathematic tool. This is integration. Integration, another mathematical operator to solve physics problems. But of course, integration there in your mathematics also, but not in the first year. That is in the second year. But before that, yes, in our first year physics, many integration problems are there. So that's why whatever may be the extent that is required to solve physics problems, up to that extent, I will explain integration in today's class. Yes, in the differentiation, any function derivative we completed. Yes, function, we can draw a graph for any function. For that graph, slope at any point completed. Nothing but derivative, differentiation. Now students, opposite of that, inverse of differentiation. So that is differentiation, change in y component divided by change in x component. That is the slope. But now opposite, y component into x component. Change in y component into change in x component. It's not now division, it is a product. Nothing but a slope. Sorry, nothing is, division is nothing but slope. Now, but today's topic is a product. Nothing but a area under the graph. Yes, in the last two classes, concentrated on slope. That means differentiation for any function. Many functions are completed. Not only individual functions, yes, combinations also over. Very difficult now, combinations completed. Now, similarly come to integration. Not the slope, it is a product, means area under the graph. Area under the graph. For example, students, yes, here y versus x. Suppose it is one straight line. Is the straight line? Area under the graph. From here to here, suppose it is y1, it is x1, it is x2. Here to here, the difference is x2 minus x1. But from here to here, height is a y1. Students, now here, this whatever may be here region there, this is nothing but a rectangle. Rectangle area we know, y1 into x2 minus x1 in the present diagram. That is the area. This is just one straight line. That's why easily we calculated from the rectangle principle. But suppose students, here function y, this is versus x. Suppose it is the graph. How we calculate area under this graph from x1 to x2? This is not now just like this rectangle. Yes, that is one curve. Area under curve means from this total area. That total area is our target. This area, nothing but a integral y function, that is function into dx. Integral. Students, integral is not a new thing. Yes, in case of mathematics, what does this sigma represent? Sigma is nothing but a summation, addition. 1 plus 2 plus 3 plus 4 plus, like that. This is the symbol for the addition. Suppose now all discontinuous numbers there, that addition is represented by this sigma. But instead of that all discontinuous numbers, continuous numbers there suppose. Yes, in between 1 and 2, many numbers there. 1.1 is there, 1.11 is there, 1.111 is there, 1.0009 is there, many are there. This all addition represented by the symbol integration. So indirectly integration is sum of many more number of infinitesimally small elements or strips or small numbers from one point to another point. That addition is represented with symbol integration. This is, students, integration is just like our symbol S. S is nothing but sum. So the same from this S only this symbol taken. This is the integral y dx. But what is the technical mathematical meaning? Integral y dx is nothing but area under this graph. Graph represented by the function y. On which axis? X-axis. Small strip length dx. But from where to where unit area? x1 to x2. This is limit x1, lower limit x1 to upper limit x2. So now today's topic completely depends on area under a graph. Total area. That is represented with the integral y dx. From where to where unit area? From x1 to x2. So x1 to x2. That is the meaning of integration first. Yes, now come to integrants of different functions. Yes, students, it is exactly opposite of our differentiation. In the differentiation, change in y components by change in x components. But in the integration, change in y components into multiplication, product, change in x component. Yes, just wait. Yes, all students know differentiation. So from that differentiation, I am explaining the integration. Just wait. There, dy by dx. Y is nothing but function of x with respect to x. It is mentioned with y prime, right? Y prime means first derivative. Y double prime means second derivative. So like that now yesterday, whatever may be the number of differentiation that all completed. Now here only first derivative I am taking. First derivative of y with respect to x mentioned with y prime. Now from this dy is nothing but y prime into dx. Students, y prime is nothing but one more function in the x. For example, if y equal to sin a ln x, it is a one function in x. But what is the derivative of ln x? 1 by x. 1 by x also one function in x. So that's why y prime is also function in x. But y prime is the first derivative of y. So now dy equal to y prime into dx. Integral dy equal to integral y prime into dx. But integral dy is nothing but a y. Y means integral derivative both opposite. Now, for example, 4 into x divided by 4. 4 cancel, x will come. Same like that now. D represents differentiation. Integral represents now integration. So these two, just like one division, one product. So cancel out, y will come. So therefore y equal to integral y prime into dx. So this you need to remember and understand. You need not remember, you just understand this. Yes, again I am mentioning y prime is nothing but first derivative of y. See now, y prime is first derivative of y with respect to x. Now, integral of first derivative of y with respect to dx is nothing but function y. function y. Yes, that side now many functions and their first derivatives already we know. Yes, suppose function is the constant, derivative is a 0. Function is x to the power of n, here n into x to the power of n minus 1. Ln x, 1 by x. A to the power of x, a to the power of x ln a. Like that now. Yes, many functions and their first derivatives already we know. Yes, previously our days now completely mentioned for only differentiation. Yes, students all solved now differentiation problems. That's why function, its derivative already we know. Y we know, y prime also we know. Now opposite, inverse. Y prime examiner will give, y you need to find out. So further, integral y prime dx is nothing but y. Examiner derivative will give, you need to find out the main function. For the main function, derivative already completed last 2 classes. Now from the derivative, main function we need to find out, opposite, inverse. So this is y equal to integral y prime dx. Yes, this now our main final result. Here I am writing, students, y equal to integral y prime into dx. Now that meaning I will explain, just wait. But before that, now here to here, first one screenshot now take now. Then later once class completed, clearly you need write the notebook. Yes, now from here onwards I will start again. Yes, this already explained from this. Next from here I will explain. Yes, so students, y equal to integral y prime into dx. Some y prime functions already we know. So that's some examples here I am writing. Yes, first, constant c equal to integral 0 dx. Same. Here y is a constant, any constant, maybe y equal to 3, 4, any some constant, a, b, c, any. So constant equal to integral y prime is 0 here. So 0 into dx. So integral 0 dx is constant, that you need to remember. Opposite, integral 0 into dx is a constant, means indirectly derivative of constant is a 0. Integral of 0 with respect to x is a constant, any constant, whatever is a constant. Yes, next to number 2, x to the power of n, integral n into x to the power of n minus 1 into dx. Because n into x to the power of minus 1 is derivative of x to the power of n. So that's why integral y prime means this one into dx equal x to the power of n. But here students, yes, this type of now indefinite integrals means suppose limits not mentioned, that integration is an indefinite integration. Suppose limits mentioned, just like the previous diagram, from x1 to x2 I mentioned now. Suppose limitations mentioned, that is a definite integration, means from this place to particular place, that is definite, but it is indefinite integration. So that's why in any indefinite integration plus some constant you need to write. Y means integral n into x to the power of n minus 1 dx. So, but this n into x to the power of n minus 1 we can write n into x to the power of minus 1 plus 0 also. But what is the 0 integral? Constant. That's why in case of indefinite integration, any integration, yes, plus some constant. But instead of that, here I am writing now this constant, any constant. Here x to the power of n plus constant. See students, x to the power of n derivative this plus constant to derivative 0 plus you can write now 0 into dx, but 0 dx already c is there. Any constant, c means not one particular, any of constant. That's why integral n x to the power of n is this type of x to the power of n original now derivative plus one constant. So it is, this function is derivative of x to the power of n. Even it is a derivative of x to the power of n plus c also, because c derivative is a 0. That's why. Okay, next. Third one, ln x. Ln x is nothing but integral y prime. What is the y prime? 1 by x into dx. So integral 1 by x to dx. 1 by x is nothing but derivative of ln x, means y prime. So integral 1 by x to dx is nothing but ln x. Just like previous, you can write plus one constant. Because ln x plus c derivative also 1 by x. Because constant derivative 0. Yes, this is now another. Similarly, you can write now all this. Integral a to the power of x ln a dx. Same, a to the power of x plus one constant, any constant. Similarly, integral e to the power of x dx, e to the power of x. Integral cos x dx, sin x. Integral minus sin x dx, cos x. Integral secant square dx, tan x. Plus constant now in all integrants, plus constant is there. Integral minus cosecant square x dx, cot x plus constant. Integral secant x tan x dx, secant x plus constant. Similarly, minus integral minus cosecant x cot x dx, cosecant x plus constant. Yes, similarly this also last I completed integral 1 by root over 1 minus x square dx, sine inverse x. Later now I suggested many all students, just like the sine inverse x, cos inverse x, tan inverse x, now all trigonometric inverse functions. That all now, yes, I suggested students solve, but how many students solve I don't know. That also now you need to complete. Yes, this is now first integrations of different functions. Integration of 0, integration of n into x to the power of n minus 1, integral 1 by x, like that all these integrants is nothing but these functions. And one more important point to students, in case of differentiation, we can find derivative of any function, no doubt, but integration not like that. Integration is to only particular functions which are derivatives of functions. That whatever may be the function is there, for that function you are going to integrate. That function, all functions not possible integration. That function definitely should be derivative of some other function. Then only you can find the integration. That's why simply integrate some function, if you write you can't integrate. That function should be derivative of some other function. So that's why integrations in any textbook now functions there, that functions only you can find the integrants. Okay, right. Now up to now what I explained, the meaning of y equal to integral y prime dx. So this how to utilize for this table I explained. Y is nothing but these functions. Y prime, these functions. Suppose here I am explaining cos x equal to integral minus sin x dx. Similarly, derivative of cos x with respect to x equal to minus sin x. That is now previous topic, differentiation. So here y prime equal to dy by dx, differentiation topic. Y prime is these functions, y is these functions. Now opposite, y equal to integral y prime dx. All y prime here, yes, y is nothing but this. Derivatives of these functions. Integrands of these functions. So both now complete. This is last topic. It is present topic. Now I am explaining again the second one. Okay. For better practice, students, for this complete table, again you please write now this type of equations on your own once class completed. Now second function, this I am writing, students. X to the power of n equal to integral n into x to the power of n minus 1 into dx. Of course, one constant is there that I am not writing. Last once problem completed, then now you can write plus c. Okay, right. X to the power of n equal to integral n into x to the power of n minus 1 dx. Just this principle I applied for the second function. Nothing written now, just only same principle I am applying for second one, this one. Okay, right. Next, but the students here, n is a constant. You can send now outside of the integration. X to the power of n equal to n into integral x to the power of n minus 1 dx. Okay. Now this n, that is nothing but one constant number. You can now send the left side. X to the power of n by n equal to x to the power of n minus 1 into dx. Right. So next I am writing, students, here. From this, please try to understand. Integral x to the power of n dx. It is n, not n minus 1. Integral x to the power of n dx, x to the power of n plus 1 divided by n plus 1 plus some constant within brackets n not equal to minus 1. Ready? Students, here n minus 1 means here n and n came. Means this number is this number plus 1. So same thing I am writing, instead of n minus 1, just n. But here n means here n plus 1 you should write. So n plus 1, same here also n plus 1. Plus c, that is mandatory. Any indefinite integration, some constant you should write. But here, students, n should not equal to minus 1. Suppose here n equal to minus 1, what happened now? This is undefined again. So that's why n not equal to minus 1, this equation is valid. Suppose integral x to the power of 1 dx means n equal to 1. Substitute n equal to 1, 1 plus 1, 2, here 2. Means indirectly x square by 2. X square by 2. Suppose integral x cube dx means n equal to 3. Same, 3 plus 1, 4 divided by 4 means x to the power of 4 divided by 4 plus 1 constant. So like that, other than n equal to minus 1. n equal to minus 1 also I will tell, just wait. But up to now, this equation, more important equation in our physics. Other than minus 1 values of small n, integral x to the power of n dx equal to x to the power of n plus 1 by n plus 1 plus constant. See students, now one time, what is the derivative of x to the power of n plus 1 with respect to dx? This is now yesterday topic. Derivative of x to the power of n plus 1 with respect to dx, n plus 1 into x to the power of n plus 1 minus 1 means these two cancel. N plus 1 into x to the power of n. Right. Now, derivative of x to the power of n plus 1 with respect to dx is this one. Suppose derivative of x to the power of n plus 1 by n plus 1 with respect to x equal to x to the power of n. Right? Same thing I am writing. This is differentiation, it is integration. Integral of x to the power of n dx equal to x to the power of n plus 1 by n plus 1 plus, so see some constant that is there, but n not equal to minus 1. Yes, so students, this formula more important. You please now try solve the problems by taking n equal different numbers. For example, 3 by 2, 5 by 2, 7 by 2, minus 7 by 2, minus 1, minus 1 by 2, minus 3 by 4. All take now, solve like that. And please remember, integral x to the power of n dx equal to x to the power of n plus 1 by n plus 1 plus some constant mandatory, n not equal to minus 1. Now, suppose if n equal to minus 1, students, n equal to minus 1, x to the power of minus 1 means 1 by x. So, 1 by x dx is nothing but, yes, go to the table students, right side 1 by x, it is derivative of what? Ln x. So that's why integral 1 by x to dx is nothing but a ln x plus constant mandatory. So that's why now finalization, integral x to the power of n dx equal to x to the power of n plus 1 by n plus 1, but n not equal to minus 1. Suppose if n equal to minus 1, answer ln x. Ln x means log x base e. This is natural logarithm. That is now ln x. Yes, I hope all students now remember this main important formula. X integral x to the power of n dx. Yes, today some problems I will give just by changing the n number, that's all. N equal to 3 by 2, minus 3 by 2, like that I will change and I will give, but you need to solve that. So now, complete meaning of x to the power of n clearly here over. Yes, you need to remember two important formulae. One is the differentiation side. What is derivative of x to the power of n? N into x to the power of n minus 1. But what is the integral of x to the power of n with respect to x? X to the power of n plus 1 divided by n plus 1, where n is not equal to minus 1. Suppose if n equal to minus 1, it is a ln x. Right? So this is now integral x to the power of n dx. Like this, students, for all these functions, you can write like that. Integral minus cosecant x cot x dx equal to cosecant x. So today you please try that. Okay. Right. Now, moving to another, you please take this first. Yes, ready? Yes, so students, now one differentiation problem. Derivative of ln of secant x plus tan x with respect to x. Derivative of ln of this function with respect to x. Student, this type of complicated problems now we can find with the help of a chain rule. Yesterday many principles completed. Yes, this is one more problem. Derivative of ln of this. How I am writing? Derivative of ln of secant x plus tan x with respect to secant x plus tan x. Chain rule I am using into derivative of secant x plus tan x with respect to x. This plus now you can use rule number 2 in our differentiation. Yes, I am writing. This is indirectly ln of function with respect to same function. Ln u with respect to u indirect. 1 by u. So 1 divided by secant x plus tan x. 1 by secant x plus tan x into, students, what is now derivative of secant x? Derivative, not integration, derivative. Secant x tan x plus, what is derivative of tan x? Secant square x. Chain rule I am using. Yes, now in the numerator, secant x tan x plus secant x. Secant x I am taking common. Secant x if I take tan x plus secant x. Numerator secant x common, tan x plus secant x. But tan x plus secant x, tan x plus secant x cancel out. So students, finally answer secant x you will get, right? So derivative of this function is a secant x. So now secant x is derivative of this function. We can write now in opposite, integral secant x dx is nothing but ln of secant x plus tan x plus constant, that is mandatory. Yes, students, integral secant x dx equal to ln of secant x plus tan x plus some constant, any constant. Yes, secant x is a derivative of this function, and integral secant x is this function. Same this I applied. Yes, students, from here to here take now from the differentiation and the integration. So similarly, you can prove, students, today once the class is completed, please prove integral cosecant x dx ln of cosecant x minus cot x plus constant. So ln of cosecant x minus cot x derivative calculation. Is it coming to cosecant x or not? Check. Then you can write now like this. So now from this table, secant to square x is there. That's why now secant x missed. That's why here I explained secant x. Yes, 0 integration. See, n into x to the power of n minus 1 by integral x to the power of n. Like that. Here secant to square x integrand to tan x. But secant x not there. So that's why one example for secant x, ln of secant x plus tan x. Ln of secant x plus tan x. Similarly, derivative of ln of cosecant x minus cot x is a cosecant x. Then you can write now integral cosecant x dx equal to ln of cosecant minus cot x. Yes, you take now from here to here. Yes, so students, now this table complete meaning over. That all now, yes, not only that now, remaining secant and cosecant also completed. These functions, derivatives, these functions integrants, these functions. And integral x to the power of n dx, x to the power of n plus 1 by n plus 1, where n is not equal to minus 1. Suppose if n equal to minus 1, that is integral 1 by x dx equal to ln x. Okay, so table completely over. Today students, now please complete, remember, not only remember that now, by taking different values now, please now try to work out more number of problems based on that table only. Okay, right. Next, just like differentiation, here also some rules there. Rule number one, integral any one constant into f of x dx. Suppose a is not function by x, a is some constant, any number, maybe plus or maybe minus. Integral some constant into f of x dx, a into integral f of x dx. Just like in our differentiation rule number also say, a into f of x derivative is nothing but a into derivative of f of x. Same like. Now second rule, same like differentiation here also. Integral f of x plus g of x with respect to x equal to integral f of x dx plus integral g of x dx. Separate. F of x the integrand first, right, plus g of x second time. Suppose here students minus is there, here also minus. So their rule number one differentiation, here rule number one, there rule number two, here rule number two, easy and the same also. So suppose now students, integral cos x plus e to the power of x dx examiner asked, suppose. Separate now, cos x integrand first, right, that is sin x, plus e to the power of x integrand, that is now e to the power of x second. Okay, so rule number one, rule number two. For understanding purpose, rule number two and rule number one combinedly one problem I will tell, just wait. Students, integral x plus 2 whole square dx is examiner asked, suppose. Yes, still minus 2 I will write. So one minus function also. Integral x minus 2 whole square dx, suppose. Integral x minus 2 whole square, x square plus 4 minus 4x into dx. Yes, so students, here x square, just like f of x, separate. First x square integrand only calculate. Next to only 4. Next to minus 4x separate. Yes, first to only x square. Otherwise, I will write here because first problem. X square dx plus students 4. 4 is a constant, so take outside. 4 integral dx minus 4 integral x dx. Here, which principle I used? Rule number 2 and also rule number 1 I used. Later, integral x square dx, integral x to the power of n dx formula. That's why integral x to the power of n dx, x to the power of n plus 1 by n plus 1. That n is at here 2. So that's why here I am writing, students, x cube by 3 plus 4 into here integral dx. Students, integral dx, how you write? Integral x to the power of 0 into dx. X to the power of 0 in the form of x to the power of n. So that's why n equal to 0, x to the power of 0 plus 1 divided by 0 plus 1 means indirectly x by 1. So x by 1 is a x. So plus 4x minus 4 integral x to dx. Yes, x to dx means x to the power of 1 into dx. X to the power of 1, that is n equal to 1. 1 plus 1 divided by 1 plus 1 means x square by 2. Plus last one constant mandatory because it is an indefinite integration. Yes, students, it is answer first. Right? So like this now, many examples today I will give in the assignment. You please now carefully integral x to the power of n dx utilize and any other functions there. Yes, already this table we know. This side all integrants is nothing but these functions. Okay. Right. So this is now today's integration of part 1 only. Tomorrow there are no big functions also there. All I will tell. That is part 2 tomorrow.